Optimization. Our objective is to apply maximums and minimums to situations. Optimization is a process of determining the best solution to a problem. So we say optimization means to maximize or minimize a quantity or situation. For example, a business owner's goal usually involves minimizing cost while maximizing profit, or an engineer's goal may be to minimize the load on a beam. In this section, we model optimization problems using a function. To optimize, find the max or min and apply that amount to the particular situation. Let's take a look at some examples. Number 1, find the length and width of a rectangle with a perimeter of 200 meters and maximum area. Now, the couple things that I highlighted here are, first of all, the maximum area. If optimization means I'm finding a max or min, I need to know what is it that I'm finding the max or min of, in this case, the area of a rectangle, and if I'm finding the maximum or minimum of it. Also, I highlighted what ultimately is the way that I'm giving my answer. I'm not ending by giving the area of the rectangle, I'm giving the length and width of the rectangle. So if it's the area that we're trying to maximize, and if it's of a rectangle, it would help if maybe I called the length of the rectangle some variable and the width of the rectangle some variable, so like x or y, and that I wrote a function based on what I'm trying to maximize. I want my function based on area. I'll choose the variable a for area, and since I called length and width x and y, the area will be x times y. Now remember that to maximize or minimize a quantity, we must find critical numbers, since maxes or mins occur at critical numbers, and this is where the function's derivative equals 0 or does not exist. Now, if I'm going to find the derivative of this area function, currently it's going to be more complicated because I'm using two variables. So it might be helpful to figure out how can I express one of the variables in terms of the other. What other information do we have? They tell us that the perimeter of the rectangle is 200 meters. To express the perimeter of this rectangle, if this length is x, this length is x. If this width is y, this width is y. And perimeter means the sum of all the sides. So I've got 2x plus 2y. That equals 200 meters. I'm going to leave the units out until the very end. Now I can solve this equation. I would like first to divide both sides by 2. So I get x plus y equals 100. And then getting y by itself, y is 100 minus x. Now I can substitute the y into the y in the area equation. So now my area equation looks like this: x times 100 minus x. Now area is all in terms of x, and the derivative will be easier. Of course, it will be even easier if I don't have a product, so I'm going to distribute the x. 100x minus x squared. Now I'm ready to find my critical numbers. A prime, 100 minus 2x, and to find my critical numbers, set my derivative equal to 0. 2x equals 100, so x equals 50. I only have one critical number, so it's most likely that the maximum will be occurring at x equals 50, but it's helpful to test to make sure that this does yield the maximum, just in case I messed up somewhere along the way. So I'm going to test using the second derivative test. I could use the first derivative and make a number line and test on either side of 50, but sometimes it's easier, depending on the function, to use the second derivative. If we look at this first derivative, our second derivative is negative 2. And notice that it does not matter what x is, negative 2 is always going to be negative. Therefore, a negative second derivative yields a function a that is concave down. That helps us because a concave down function, where there's a critical number, yields a local maximum. So testing that shows that I do have a max at x equals 50. Now remember, we ultimately need to answer the question to in this case, find the length and width of the rectangle. So I have x is the length, 50. I'm going to plug that into what y equals. Y is 100 minus x, so 100 minus 50. So y is 50, and my length and width are 50 meters and 50 meters. I'm writing the dimensions of the rectangle, 50 meters by 50 meters. And there we have it.